Let a1, a2, a3 and so on an, where n is greater than 2, be the vertices of a regular polygon of n sides with the center at origin and side length of 2 units. Let ak be the position vector of the point ak, where k is 1, 2, 3, so on. If this expression is equal to 400, find the value of n. Let this be an n-sided polygon. Here a1, a2, a3 and so on up to an minus 1 and an represents the vertices, and if we join from origin to the vertices we get respective vectors. If I join O to point A1, I get A1 vector. From point O to A2 we get A2 vector, and similarly from O to A3, A3 vector, and so on so on. From O to AN we get AN vector. Since the vector is n-sided regular polygon, so that means the length of each side is equal, and it is given that it is equal to 2 units. And the angle subtended at the center is theta, and each angle here is equal to theta. Since the polygon is regular, so the angle doesn't change, and theta here is 2 pi by n, because entire 2 pi angle is divided among n parts. And similarly the length of the vectors are also equal, so length of the vectors is equal to L. Now take this triangle OA1 AN first of all, and from point O we dropped a perpendicular at point M, so this entire angle gets bisected and this angle becomes here theta by 2, and this also theta by 2. Since it is a perpendicular bisector, so A1 to AN length gets bisected into 1 and 1 units. Now in triangle OMA1, sine of theta by 2 is equal to 1 upon L, and from here L can be written as 1 upon sine of theta by 2. Since theta is equal to 2 pi by n, so L becomes 1 upon sine of 2 pi by n into 1 by 2. So L becomes 1 upon sine of pi by n. Now it is given that this expression is equal to 400. So this part here represents the cross product of AK vector cross AK plus 1 vector, and here it is sigma. Applying summation on this A1 vector cross A2 vector plus A2 vector cross A3 vector plus so on up to AN minus 1 vector cross AN vector whole modulus square plus, now applying summation here we get A1 dot A2 vector plus A2 vector dot A3 vector plus so on AN minus 1 vector dot AN vector whole modulus square is equal to 400. Since we know that A cross B is equal to mod A mod B sine theta n cap, and A dot B is equal to mod A mod B cos of theta. Applying these two definitions here, since we assume that the magnitude of each vector is equal to L for a regular polygon, so the entire expression becomes now L square sine of theta into n cap for n minus 1 times. This combination of cross vector occurs for n minus 1 times, and there is modulus with the square, plus similarly there is dot product of the vectors for n minus 1 times. So L square into cos of theta into n minus 1 times with modulus square equal to 400. Common, we get L square into n minus 1 common with the modulus whole square, and we get sine theta square plus cos of theta square inside the bracket equal to 400. This is equal to 1. So finally we have L square into n minus 1 modulus square equal to 400. Taking under root, we get L square into n minus 1 equal to 20. And since we know that L is equal to 1 upon sine of pi by n minus 1 upon sine of pi by n whole square equal to 20. Now if we pay attention, for n equal to 6 only, we get 6 minus 1 into whole divided by sine of pi by 6 whole square, which is equal to 5 upon sine pi by 6 is 1 by 2 and whole square, and this becomes 5 into 4, which is equal to 20. So only n equal to 6 is the possible value